Drop test is an important standard process for many products that are at risk of being dropped. This test does not only concern cell phones and electronic devices, but also expensive lab equipment, personal computers, etc., whose prices are not compatible with poor quality. When simulating a drop test with the goal of virtually checking if the device is going to survive, nature has left engineers with no choice. Many phenomena that happen in reality have to be dealt with through nonlinear finite element analysis. Simcenter 3D simplifies the process of creating nonlinear models, as we are now going to show through an example. Here is our model already imported and meshed in Simcenter 3D. It is a mix of shell and solid parts. Our goal will be to calculate stress history during and after contact with the ground in order to check if the component will be safe at the end of the test. The simulation starts just a short instant before contact. We select Simcenter Nastran Sol 402, the nonlinear multi-step implicit solver of Simcenter 3D. We also take advantage of high-performance computing technology. Initial velocity has to be defined corresponding to the drop test scenario. Of course, contact will be the first and most important nonlinear phenomenon to be taken into account. Simcenter 3D allows to define contact conditions based on geometry. We select the whole bottom part of the component as the place where contact may happen. For drop test simulation, nonlinear dynamic solver is selected. We have to take into account not only inertia, but also any damping that may occur during and after contact, as local stresses will be highly influenced by the capability of the material to dampen the shock energy. And when dynamics are in the picture, time-step management may become problematic. Luckily, Simcenter 3D proposes automatic time-step strategy, making the definition of the problem especially user-friendly. As it can be seen, contact is calculated and maximal stress computed by taking the proper material behavior into account. The virtual test accurately reproduces reality, allowing the engineer not only to save a lot of time and money, but also to access a better design by answering multiple what-if scenarios when looking for the optimal design of the component.